response from a speed of the
If someone's injured and we can't find them, seconds matter.
Helps us cut down on outages, wildfire detection.
I want people to feel safe in their communities.
DFR2, area is clear. Launching DFR2.
AEP Ohio installed its first drone docking station.
First of its kind program is taking flight.
We're launching a new drone program.
As first responders.
Launching from the roof of police headquarters. They're not just going to outages, they're trying to prevent them.
We now can send a drone instead, capture the images that we need to see.
Automation missions planned out, flying our infrastructure.
When the emergency call comes in, every second counts.
The drone spotted him in the woods.
This life-saving technology, gearing up their drones with flotation devices.
Used to help save swimmers at sea.
Drones commonly used in the military. This one right here, called the Skydio, is our most popular one.
Unleashing American drone dominance.
Nothing has provided the level of confidence that the X10 does.
On the ground!
When he saw the drone, he knew he was caught.
Drone pilot got on scene, observed a guy holding a shotgun.
The DFR drone actually beat me there.
You could see his outline, and then you could see him moving. We're like, okay, we got him.
Here they're using the drone to locate someone.
Hey, the drone has somebody running through the woods.
Flown it in rain, snow.
Through the day, through the night.
We're currently flying right now. He has been super successful.
We're not waiting for the future of policing, we're building it.
Police say it is a game changer.
Sheriff calls the drones a game changer.
Game changer.
Game changer.
A game changer.
One of the most significant paradigm shifts I've seen in my career.
Please welcome to the stage co-founder and CEO, Adam Bree.
Welcome to Dronehenge, everyone. This is such a special moment for drones. You can just see it and feel it. The way we use these things is fundamentally evolving, and it's having incredible positive impact. And this is such a special group of people. You all are the ones making it happen. Now, from a Skydio perspective, almost everything that's happening out there now is downstream from what we've announced on stage at Ascend. 2 years ago, our first Ascend event, we launched the Skydio X10, and just to make sure that NightSense worked, we flew it at my head in zero light on stage. It did work. And in the 2 years since, you guys have done incredible things with it. It's helped with storm response, it's fighting crime, it's inspecting our infrastructure, and it's helping to protect our soldiers and our allies around the world. 1 year ago, we launched the dock for the X10, and this completed the story of autonomous, remotely operated drones. And just to prove that it could land in challenging conditions, we blasted it with 30-mile-an-hour winds and rain on stage. It worked again. In the year since, it started a paradigm shift in how drones are used. So I'm very proud of these products. I'm proud of the demos that we gave on stage to launch them. And boy, do we have some exciting stuff to show to you today. We've got a bunch of new products. We're going to demonstrate all of it live on stage for you to see. So stay tuned to the end. Now, our core identity as a company, our mission, is building flying robots that give people superpowers, that give you and your organization superpowers. And we are very passionate about the technology. I'm probably not neutral on this, but I think this is the most fun, exciting stuff imaginable to get to work on. And we see a lot of that technology passion reflected in our customers. But our deep motivation starts with who we serve. We're fortunate to work with an incredible group of customers, spanning law enforcement, fire, energy, construction, transportation, and the US and allied militaries around the world. If we want to think about where the industry is going, I think it's helpful to take a little bit of a step back and think about where we've been, the evolving role that drones have played for civilization. So the class of drone that we make, these kind of small electric quadcopters, these things really started off as kids' toys. And this is the world that I come from. I grew up flying radio-controlled airplanes. It was super fun, but it didn't really have any impact beyond those who flew them. These things were fun to get to fly, but it was really just a hobby. A little over a decade ago, people realized that if you put a camera on these things, it's an incredibly powerful tool. And this first showed up for cinematography, capturing cool video, but it quickly spread to real-time situational awareness, infrastructure inspection, and so on. I kind of think of this as the tools era, where you can do useful stuff. It requires a skilled pilot there on site. So I always think the future is here. It's just not evenly distributed. And if we want to know where we're going, we can look to what our most advanced customers are doing today.
The docking station is here at the substation for the Clintonville and Linden neighborhoods. The drone is stored inside of this, and with it already being in the area, AEP Ohio is able to be looking at the outage spot within minutes.
The intent is that we identify the solution quick, and then at that point, the line crew's on site, ready to make the repair.
The docking station also allows them to pilot the drones remotely.
When there's trouble, with the click of a button, we're able to deploy the drone from here in headquarters in Gahanna.
So they're not just going to outages, they're trying to prevent them.
In the past year, we found almost 300 instances where we fixed an outage before it happened.
So it's all about keeping the lights on, which means going down less and getting back on faster. And AEP is transforming the way this is done with docked drones. I think this is clearly an exciting time for drone as first responder. We really think of this as the year of DFR. One of our first DFR customers was Oklahoma City Police Department, and one of their first incidents was this. So a train operator called 911 in a panic, afraid that he might have hit somebody on the tracks. They launched the drone. They got there in a few seconds. They were able to see that, unfortunately, there was a homeless person asleep on the tracks, but because they could locate him so quickly with the drone, they were able to guide in first responders, got there, got him critical care, and saved this man's life. Incredible work by Oklahoma City Police and Fire. Another example, San Francisco Police Department. So San Francisco Police Department got a report of a stolen vehicle. They launched the drone. They're able to quickly locate the suspect from the air. And this gives the officers an incredible asymmetric advantage. They can follow him around. They know exactly where he is. They know exactly what he's doing. He stole the vehicle. Now he's going to steal some plates to put on his stolen vehicle. So this is bad news, right? This is the beginning, likely, of a serious crime spree. He's cold-plating the vehicle, takes the new plates, puts them on. He very graciously holds up the new plates so that we can read them from the drone. Doesn't know that he's being followed. I didn't know what was happening here. Some of you can probably predict it, but he's putting window tint on. So he's clearly stolen the vehicle. He's getting ready to go off and do some bad stuff. But because they're following with the drone, they know where he is, they know what he's doing. They can pick the time in the moment to intervene. So they sent a plainclothes unit. They rolled spike strips, put an end to this, took him into custody. Safer for everybody involved. Incredible work by San Francisco Police Department. So the core idea of drone as first responder, using drones to respond to critical incidents, get real-time situational awareness, extends beyond state and local law enforcement. So this is an example from the Bluegrass Army Depot. We deal with all kinds of serious security incidents on base. This is a training exercise for an active shooter situation. So they're practicing here using drones to get them in the air quickly as part of the physical security group, get real-time awareness, and resolve the situation faster and safer. What's the common thread between all of these? So in all these instances, we've got a docked drone that can be flown fully autonomously or operated remotely. It's a fundamental difference from the old way of using drones. It used to be you send a person out there, they've got the controller, they launch it, they fly it, that's fine. But this is just a step change in efficiency and impact. So when we're thinking about like what concept, what word captures this, we realized that the inspiration was right there in front of us with the industries that we serve. Infrastructure. Definition of infrastructure, the basic physical and organizational structures and facilities, buildings, roads, power supplies, needed for the operation of a society or enterprise. So I think we're entering a fundamentally new era where drones themselves become critical physical infrastructure. And the impact and importance is going to be off the charts compared to what we've seen previously. This ties to the founding bet when we started Skydio 12 years ago. Now, I can't say that we perfectly predicted the future, but we had a deep belief that if you could make these things smart enough to fly themselves, they'd be useful to more people in more places. And for the last 7 years, we've been laser focused on bringing dock and remote operations to life. We didn't do it all at once, we did it incrementally. We built the vehicles, we built the connectivity, we built the dock, and now we've gotten to the place where all this stuff is working together in your hands. It's been incredibly gratifying for us to see it scale up. So all of these are active X10 dock locations now, and there's hundreds more right around the corner coming. One of the things that's most exciting is looking at the data that we're getting from our early usage. So early results show that dock-based X10s are flying 4 to 5x as much as conventional X10s. Conventional X10s were already being flown a lot, but dock just removes all the friction from getting these things in the air, which is exactly why we built it. And what this means is we're getting a lot of flights. So we like to do the historical comparisons here. This is our first generation of products, Skydio 2 and X2. And when we launched X10, starting from the date of first shipment, it blew it out of the water. And dock and X10 are now blowing this out of the water. So we're fortunate to work with an incredible group of customers across a wide range of industries all over the country. One of the true pioneers that we've had the fortune to work with over the last 2 years is the New York City Police Department. This is the biggest, most complex city in America, and they've done incredible pioneering work to stand up a totally game-changing drone as first responder program. But their vision, the city's vision, goes beyond law enforcement. They were early in realizing that these same drones that can be used to respond to 911 calls and other emergencies can be used for all kinds of different opportunities across the city. And I'm very excited today to have New York City's Chief Technology Officer, Matthew Fraser, join me here on stage to tell you a little bit about what they're up to. So please welcome Matthew. Skydio casual, I like it. Yeah. So from our very first meeting, it was clear that you all saw the potential of this. Obviously, law enforcement is incredibly impactful, but it was clear that you guys had a vision beyond that. I'd love to hear kind of where that came from. Can you share with folks, like, how did this idea start for you guys?
Yeah, so when you look at the modern era and you look at how technology has evolved almost every industry, look at the medical industry, look at the transportation industry, look at what Uber has done for public transport for people. So when we look at technology, we try to look at it from the lens of how can it help the masses, what's the utility behind it, and how and what areas are we critically underserved today. So when we looked at drones from the public safety perspective, the outcomes, the use cases are very easy to see. It was good. It's a very good use of the technology. But outside of that, think about how many other industries, how many other service lines the city represents where we have challenges where we need someone to go out and check something, report back, and then we take an action. So when I think about that, I think about stuff like our buildings department. The New York City Department of Buildings is one of the largest safety regulatory agencies across the entire US. There's over 1 million buildings in New York, and they're responsible for ensuring that the code and safety of those buildings are up to par. So imagine having a facade-related issue where we have debris falling because of the external side of the building hasn't been properly maintained, and you want to assess the extent of the damage. So instead of having a buildings inspector coming out from the street level, taking a look up, going up as high as they can within the facade, taking a look out the window, looking at what the facade looks like, having a drone being able to survey the building in real time and tell us what's happening. Think about what we do around after-hours work. You have job sites that have construction activity after permitted hours. Instead of sending a building inspector out to take a look at that job, having a drone go and do a flyover to see if we see equipment moving on the job site to show us that that activity is there. And then being able to have higher quality and faster levels of enforcement behind that type of activity. So when we looked at drones, we said the use cases for this is much bigger than just the public safety space. And if we only invest for one vertical, we'll lose the opportunity to capture everything else that we can do within the city. So what we decided to do is have a citywide drone program. So we looked at the geography of the city, we looked at how we could break it up and how we could get drone coverage in almost every space. And we've been partnering with Skydio and working on rolling that out throughout the city. So now whether we have a construction-related incident, whether we have an emergency-related incident related to public safety or something like a building collapse, or whether you need to do a survey of some other underground structure or above-ground structure, being able to have the utility of using those same devices that we put out for the public good, for public safety, be used to help in all those other areas.
It's fantastic stuff. So we've started to hear this idea percolate a little bit in other places of having drones become city infrastructure, county infrastructure. Do you have any kind of advice or thoughts for other city leaders or public safety leaders out there that might be thinking about this?
Yeah, so I think as you look at investing in these types of technologies, and you look at where you position your drones, take a look across every service line that you run, whether that's the engineering and operations side, whether that's buildings, whether that's water infrastructure, whether that's public utility infrastructure. And take a look at wherever you have a person that goes out to do any manual level of survey, externally around a facade or anything around the stability of a building or anything along that lines, and use that as an opportunity as you're doing the use case around whatever your initial use case is. Build pilot use cases in each one of those areas so that you can prove the value. So it's always hard to justify why are we going to invest in this and why is that and how's that going to pay the city back in the future. When we look at it from a New York City perspective, faster times to inspect buildings, faster times to inspect roadways, faster times to inspect bridges and other types of infrastructure, and the safety-related conditions that those things can bring, the cost will return itself tenfold very quickly if you look at it through that lens.
Awesome. Well, thank you, Matt. Thanks for joining us here today.
Happy to be here. Thank you.
One of the implications of this, if drones themselves are going to become physical infrastructure, the national security stakes are going up. These are network-connected, flying autonomous robots. But the national security stakes have already been super high. It's crystal clear at this point that drones are the fundamental critical tool on the modern battlefield. And the Department of War is now fully changing the game. We've been working with the Army for the last 6-7 years, and we have never seen the pace, intensity, excitement of deploying these tools to our soldiers. I'm very excited and proud that Skydio is a part of the Army Short Range Reconnaissance Tranche 2 program to get soldiers the capability that we need. And we see serving both our military and our civilian customers as a critical national security imperative. So when we started Skydio, we've always built our drones in-house in the United States. And when we started doing this in 2016, people thought we were insane. The conventional wisdom at the time was like, you got to go to China. That's where all consumer electronics are manufactured. You'll never be able to do it in the US. We always felt these things are aerospace devices. In the aerospace world, manufacturing and design end up pretty closely coupled. And over the last nearly 10 years, we've built up phenomenal manufacturing capacity right here in the US, which has now become a critical strategic advantage for us as a company, and I think a critical strategic advantage for us as a country. The other implication, if we're building physical infrastructure, is that reliability is the single most important feature. You can have great capability, but if it's not accessible when you need it, it doesn't really matter. I will note that the sun is now coming out, the fog is burning off. If you don't have a hat, I think we have some extra hats in the back. I tested this myself yesterday. The hats make a big difference. Just get the bill down. The sun's at the perfect angle. So maybe if we have some Skydio people, we can literally pass the hat. Building really good, reliable drones is a phenomenal technical challenge. I think it's kind of deceptive because they're so small, people think it might be easy, but the level of technical complexity is really on par with building a self-driving car, building a rocket ship, and it's actually harder making it smaller. Like in engineering, oftentimes the way that you solve tricky problems is by adding mass or taking up space. In a drone, we're packing a huge amount of technology into a very, very small package. I think there's really two keys to achieving high reliability on these systems. The first is controlling the entire technology stack, and we are a full stack company. So we design the drone, we design the dock, we manufacture these things ourselves in-house. We also write all the software that runs on the drone and software in the cloud that manages all of this. And I can tell you from hard-earned experience that oftentimes what it takes to fix a tricky issue is tweaking all of these things. We'll make a subtle software change, we'll tweak the design, we'll change the manufacturing process. All of that stuff together is critical for making these systems work the way that we want to. The other ingredient, though, is just real-world experience. There's no substitute for getting out there and flying in challenging conditions and learning the hard lessons that come from more and more data. And we are fortunate now to have a lot of data. So our online vehicles, basically those serving our civilian customers, the report analytics up to the cloud, have done 2.6 million flights. The actual number is probably double this because a lot of our drones are going to offline military uses. We're now getting close to 1 billion analytics events per day, and we've got over 4 petabytes of log data. A lot of this is data that we've generated ourselves. Some of it is data that customers have voluntarily shared back with us. And all of this is being used continuously to improve the system. Now, I want to continue what will be an ongoing tradition here at Ascend, which is sharing openly some of the biggest reliability issues that we've had over the last year. I'll talk a little bit why we think that's important. So the first one is this. Now, this is going to look familiar to some of you out there in the audience. Internally, we call this the red LEDs of death or the white LEDs of death. And basically what would happen is if you're flying X10, you would see these LEDs show up, the drone would disconnect. Now, fortunately, in the vast majority of scenarios, it will safely, autonomously return to home, land itself, but it still kills the mission. It's an unacceptably bad user experience. I want to talk about what's going on here. So we obviously do a lot of RF testing before we ship a device. We do all kinds of different exposure, different chambers, but we miss something. And unfortunately, we miss something that is near and dear for many of our customers. So that is a police radio, and it turns out that the power and frequency that that thing operates at, if you hold it just on the left side of the controller, where many of our customers have their radios mounted, it interferes with the signal, and in extreme cases, it can actually damage the controller and brick it. So here we're looking at the back side of our controller. It's kind of opened up. We've done a bunch of things to address this. So the first is just shielding the power cable where the signal is getting picked up and amplified. We've redesigned the battery circuit, and a lot of this can actually be improved in software. So all of these fixes are rolling out now, and they have a huge impact. They basically fix 91% of the issues, and 33% of it can be fixed through software alone, which obviously all of our customers will get without having to get new hardware. Second reliability issue, propellers. So all Skydio customers over the last year have gotten these notice to operators advising to inspect your propellers, watch out for propeller wear. If you see the propeller hub worn out, you need to replace it. Today I want to share what's been going on behind the scenes. So we do a ton of reliability testing before we ship these things. We shake them, we vibrate them, we bake them, we freeze them, and we tested the crap out of the propulsion system too. We did hundreds of cycles, hundreds of hours on individual units in all kinds of extreme conditions. By the time we shipped, we'd accumulated over 2,000 hours of real flight data on our X10 fleet. But after we shipped, one of our wireless testers had a crash out in the desert. So this guy's name is Frank Testa, perfect name. He lives in the desert. He tests the wireless system. So basically, all day long, he just flies out and back at max speed to stress the wireless system. So we started to investigate this. We looked into the data. So here we're looking at distance traveled versus total flight hours for our entire X10 fleet. Each of these dots is a drone. This is kind of like the upper bound for the majority of the distribution, and this is Frank's vehicle, because all he was doing was like max speed back and forth all day long. When we investigated, we found this. So there's a steel hub, there's a steel propeller shaft, there's an aluminum hub. Those things were grinding at prolonged exposure at max speed. So the first thing we need to do is find a way to replicate it. So we built this thing we call the windstorm. So it mounts the drone at a specific angle, cycles the propulsion system, and then applies a ton of external velocity to really torture it. So using the windstorm setup, we were able to replicate the issue, and once we can replicate it, we can study it, we can try to fix it. So here's our original design. We started playing around with more materials and more geometries. And this was a very tricky problem, because we couldn't change the motor or the shaft design. You guys have the drones. We can't ask you to install new motors. We can only change the propeller design. So we tried a first set of designs. We tried more designs. We tried more designs. It really turned into a true material science problem. But we did find, our team did amazing work here, we found a recipe that worked. We basically found that a more compliant propeller hub material with better geometry offered a 35x improvement in durability in the most extreme flight conditions with the drone maximally loaded. And many of you already have new propeller sets. Those that don't will be getting at least one free set by mid-November. But there was a time issue here. It took us a long time internally to find a fix that we found to be acceptable that offered the durability improvement that we needed. So our first NTO, these are notice to operators. Key thing for us is once we find an issue, we're going to tell you about it. Went out in May 2024. And in the intervening time between that first NTO and when we had the fix, we proactively contacted customers to replace 240 propeller sets. And because of that, the issue was 98% contained before we had the root cause technical fix. So how did we do that? Well, once we understood what was going on, we built an analytics model that enabled us to look at our fleet data and figure out any drone that somebody was flying that was getting anywhere close to the risk profile, and our customer support would proactively contact any vehicle that we thought was at risk to warn them and have them replace the propellers. And while we were doing this, we also built it into the product. So the drone itself can obviously track its flight time, and we built UI into the controller and remote flight deck so that you would know to do this. So I think the overall punchline here is that data and software maturity combined with close collaboration with you all enabled us to contain this issue. And I think that's a story that's going to continue. Now, why am I here on stage? This is the biggest stage that we get as a company, our most important event of the year, and I'm talking about stuff that we messed up. So there's a couple reasons for this. One, we are accountable to you. Reliability is the most important feature, and I want everybody here to know that we view it that way. When we mess up, we're going to talk about it, we're going to share it, we're going to fix it, we're going to improve it. But the second reason is a little bit broader. I think transparency is actually foundational to safety reliability in aviation. The more that we talk about this stuff transparently, the smarter we can all be, the better judgment we can exercise, the better decisions we can make. And we're taking the next step on that today. So I'm very excited to announce that starting today, we're going to have a public-facing reliability dashboard where we publish our internal reliability metrics. So we scrutinize this stuff immensely internally. We're going to start sharing it with the world. So I'm going to give you a quick overview of what's in there. So the overall thing that we're focused on is what we call the flight incident rate, which I think is aviation and marketing speak for a crash. Somebody on our marketing team just winced back there. I can see Macario. From here on, we'll just call it flight incident rate. So this is the actual data. So this is rolling data for the last 90 days. And then we're going to break it down into the constituent components. So the first, and this is obviously what we're most focused on, is technical malfunction. So these are things like the prop hub failure that we talked about, but we also count, and this is setting an extremely high bar for ourselves, any failure of the collision avoidance system we are counting as a technical malfunction. So any little thin wire, thin branch that the drone clips, we count that against ourselves. Now, fortunately, the collision avoidance system is really good, and it works really well most of the time. So this is an actual customer flight where it's returning home, weaving its way through everything in its way. If this had crashed, we would account this as a technical malfunction. That's the bar that we're setting for ourselves. But there's other things that go into this as well. So there's environmental factors. Bird strikes happen. We have enough data now that we see this on a monthly basis. We've had drones get intentionally shot at. You could call that a human factor. We call it an environmental factor. You could fly in icing conditions. And then there are true human factors. So these are things where basically the drone was being operated outside of our recommended design procedures. Now, we know these things are operated in stressful situations. Oftentimes people are exercising judgment, knowingly taking risks. Somebody might choose to turn off obstacle avoidance, resulting in a crash. We also view this as our responsibility, and we're continually trying to improve the product such that it's less and less likely for these human factor issues to happen. But the trend is very strong. Because we're so focused on this, we just see it month over month, release over release. We are making progress. You also start to see, and I don't think we have enough data to fully claim this, but you start to see some seasonality there. It looks like summer flying is a little safer, winter flying is a little bit more dangerous. There's less flying in the winter, which means we're more sensitive, but the environmental conditions are also harder. There's more thin branches without leaves on them, things like this. The other key thing that we're tracking is dock landing reliability. We're currently at 99.6, so this means you do 1,000 flights, somewhere between 3 and 4 of them might land outside the dock. I want to be clear, these are not crashes. We have the safe landing spot. The drone will just go there and land. We really want to get to 3 nines of reliability. We're cranking away at it. I think we're pretty close. From a broader perspective, all aviation entails some level of risk. Whether you're flying an X10, a helicopter, a commercial jet, anytime something takes off, the entropy is trying to bring you down to the ground. And so it takes a lot of technology to keep things in the air. There's 2 ways that you can break this down into 2 components. So we think of risk as sort of the combination of the likelihood, how probable is it that something is going to go wrong, and then the severity. If something does go wrong, how bad is it going to be? So we looked high and low, and we really couldn't find any rigorous data sets out there for small UAS. We believe that we are the first company to really rigorously track this stuff. And small UAS are going to have a higher incident rate. These things are flown low to the ground where more things can go wrong. And because they're small and light, there isn't as much room for redundant systems. But the size and weight trade-off is more than worth it because the severity is very, very low compared to manned aviation. And if you multiply these things 2 together, the punchline is that X10 is super safe. It's way safer than putting a helicopter in the air, which is oftentimes the alternative for our customers. One of the levers on severity, if we want to keep driving this down, is kinetic energy. It's a combination of mass and velocity. So this is why we developed the parachute. Parachute reduces the kinetic energy by an order of magnitude, deploys, keeps everybody on the ground safer. I don't know about you, but I'm not used to thinking in terms of joules, so to make this a little bit more perhaps understandable, it's the difference between getting hit by a baseball going over 150 miles an hour to one going 36 miles an hour. And it's worth noting here that a bigger drone falling from 300 feet would be equivalent to getting hit by a 360 mile an hour baseball, which I don't think anybody wants to sign up for. And it's really important to keep this in mind. Size, mass, velocity, these things are bad. We just wanted to demonstrate that kinetic energy is bad. So it's still a new product, but Parachute has already had 3 successful deployment recoveries. We're not rooting for this number to be higher, but we are glad that it's out there. And with Parachute, the risk is reduced by another order of magnitude. We're having to make some inferences here because we don't have as much data as the whole history of commercial aviation. But commercial aviation is the gold standard of aviation safety, and we believe that with Parachute on a per flight hour basis, X10 is safer than everything else out there. The other good news is that dock-based flights, again, early data, are looking 3x safer than controller-based flights. And overall, X10 is now 4x safer than when we launched it. The vast majority of this is coming through software improvements that are available to all of our customers. So we've got greatly improved reliability. What about capability? Well, there's different dimensions to capability. If you're flying from a dock, launch time really matters. Connectivity is obviously critical. Charge speed matters. It matters a lot in docks. Top speed, flight time. We're trying to optimize all this stuff. So we'll start with flight time. Our Gen 2 battery has significantly increased capacity. So we got out of China, and we got a win in terms of capacity. But in order to use that capacity, you need to have a really good model of it. You obviously don't want to return home too late, so you need to model out exactly how the battery is going to behave in different situations. We've put a ton of time into this. We've also then optimized our flight control system so it can squeeze every last drop out of the battery. We're improving the onboard estimation so that you know the local weather conditions, which is another key ingredient in getting more endurance out of these things. And then we're also continually just optimizing how the drone uses its own power systems. And the net result of this is during daytime operating conditions with upcoming software improvements on Gen 2 batteries, we're expecting roughly a 3-minute improvement in average flight conditions. Night sense, flying at night and active illumination, is going to use more power, but we've done a ton of optimization there, and we think unlocked an additional 7 minutes of flight time. Airspeed, another critical ingredient. So the max airspeed of X10 has always been 45 miles an hour, but the max obstacle avoidance speed was 36 miles an hour. And if you look at the data, basically nobody's flying faster than 36 miles an hour, which makes sense because people want to have obstacle avoidance on. We have now done the work to bring obstacle avoidance to 45 miles an hour. There's a ton of science behind this to make the calibration system be able to see obstacles far enough away so that we can fly at higher speeds. And then because we know if we unlock that, people are going to spend a lot of time flying at higher speeds, we're doing a ton of reliability testing on fully loaded X10s to make sure that it can stand up to this. So this will also be coming in an upcoming software release. So Gen 1 dock takes about 36 minutes to go from 0 to 80% state of charge. We've got a Gen 2 coming soon that'll take that down to 25 minutes, so it's a 30% increase in charge time. This will come with all new docks, but will also be a free upgrade as part of our normal annual maintenance for all docks that are already out there. And this might sound like not that big of a deal, but it's actually a huge deal. If you think of about a fleet of dozens of docks, increasing the charge speed by 30% is a huge increase in the capacity of what that overall system can do. Connectivity. So we've got our point-to-point radio, Connect SL. We're bringing adaptive channel switching. So this doesn't happen that often, but if somebody happens to turn on and drive interference on the channel that you're operating on, it's a terrible experience. So this will dramatically improve the worst 20% of flights. But we think the real key to robust connectivity is having multiple links. So we've got Connect SL, which is our point-to-point link. But this is great if you're flying close to the base station. We think 5G, especially in urban and suburban environments, is a key ingredient, which is why we built 5G into the drone. But now with Fusion Plus, you can have 2 onboard 5G modems, and Fusion Plus brings all of this together. It's a huge step up in robustness. It's also a huge step up in the max that you can get because it's additive. It's both redundant and additive. Fusion Plus, at the operating system level, can send data over multiple links. This works on T-Mobile, Wireless Priority Service, AT&T, FirstNet, Verizon, and in Japan, KDDI and NTT. So with Fusion and Fusion Plus, we're seeing a 38% improvement in the robustness of the link, The other piece is obviously the quality of the video that you can get. So as you would expect, Connect SL falls off with range. Fusion brings that up to pretty much a pretty good flat line. And Fusion Plus is a huge step up on top of this. Time to launch. This is probably the #1 thing that we've heard about, especially from our DFR customers. We want to get in the air faster. So right now, there's 3 or 4 things that have to happen, some in the cloud, some on the drone. They kind of happen in series. We've now optimized all of them, scrunched them down in parallel. So we're going from 25 or 30 seconds down to 10 seconds. So we've got 2x faster launch, 38% more robust connectivity, 30% faster charging, 25% higher top speed, 10% longer flight time, bunch of other software improvements. It's basically a whole new X10. Gen 2 comes with all of this, but almost everything applies to Gen 1 as well through software improvements. And this is kind of a core philosophy for us. We're not trying to sell a new piece of hardware every year. We're trying to continually invest in the platform, make it better, more useful for you guys. Precision mapping is one of the well-established drone use cases. And this is one, honestly, where we're a little bit late to the party. Lots of folks have been doing this across construction, transportation, surveying. I'm very excited to share that X10 is now high precision capable. So we've got the RTK attachment, and we've also done the software work to unlock the necessary mapping flows. The big question was always rolling shutter. Raise your hand if you were concerned about rolling shutter on X10. At least a couple of hands went up there. So for those that don't know, and I can't blame you, basically every camera in the world exposes line by line. It doesn't read out the whole frame at once. It exposes line by line. And it happens very quickly, but if the drone is moving, you end up with this effect where you get skew in the image. The drone translates over time. It's not all captured at a single instant, and that results in skew. But if you're good at math, and we have some folks at Skydio who are great at math, you can fix it. So you basically precisely estimate the motion of the drone during the capture period. You need to know how far away the thing you're looking at is, and you can unwarp it. And you can see this very clearly at the data. So here we're comparing a test we did with RTK, but no rolling shutter correction, to having rolling shutter correction. Lower is better here. This is centimeters of error. So it basically perfectly corrects for the motion. And we're comparing it to other competing products out here. We're not claiming that we're the best, and there's a bunch of different ways that you can test this, but we are well below sort of the survey grade bar that we expect, that most of our customers expect. Most importantly, we're hearing this from you. So same accuracy as a Phantom 4 RTK in a third of the time, sub-inch results in many scenarios. It's very exciting to see this. It's more exciting, I would say, to see this happening from docks. So Turner Construction has been doing awesome work here to have these RTK drones installed on their construction site to just be continually flying and operating in the background. They're going to have an information session later today, which I highly recommend everybody go check out. So capture is part of the story, but it doesn't exist in a vacuum. You need kind of the complete workflow. And we're also working with industry leaders like Drone Deploy, Pix4D, Propeller, Esri, Trimble, and more to deliver the end-to-end precision mapping workflow. So this was always part of the big thesis on X10, that we're going to build a bunch of attachments and accessories to unlock more and more capability over time. We're going to keep building more as we see need in the market. And one of the most common requests that we got was for something like this. The dropper. So this was a huge ask from public safety, to be able to drop a rest tube to somebody in need, maybe Narcan, maybe a battery, whatever the situation demands. And today, we're introducing our interface control document. So this is a public-facing standard interface that anybody can use. So if we don't make the attachment that you want, you can use the ICD to develop it yourself. So we've got 4x reliability. We've massively expanded the capability, mostly through software and attachments. What about operational efficiency? So we think the key metric here is really how many useful flight hours are you getting for every person hour you invest. We love to study things with data, so we've actually built a simulation environment for drone as first responder, but you could do this for other applications as well. So it's very data-driven. This is a data set from Clark County, so Las Vegas Metro Police Department, 500,000 calls for service in the data set. And you can basically simulate the impact of having different number of drones. So on the right, you're seeing a map of possible deployments. Each of those red dots is a hive of 3 docks. On the left, you're seeing a response time curve. So what percentage of calls are we getting to, and how quickly are we getting to them? So you can see with 15 docks, pretty good story. We could respond to maybe the most important 10 to 20% of calls. The more docks you add, the story gets better. 44, we're getting to more faster. 168, better again, more faster. We're in the business of selling drones, but I think in most situations, more drones is going to be better. How are we going to staff this? So if you have 15 docked drones, if you needed a 1-to-1 ratio between people and drones, you would need 15 people in an ops center flying these things. And I would say with 15 people, it maybe seems plausible that you can do that. At 44, it doesn't look so appealing. At 168, it's kind of outrageous, right? You need like a whole gymnasium full of folks flying drones remotely. And this is just not the way that it should work. We see this very practically. Oftentimes with our customers, the #1 barrier to starting a drone program is finding the people to staff it. And for sure, at scale, the #1 cost of the program is going to be the people to run it. And the drone should work for us. It shouldn't be the other way around. The answer is AI and autonomy.
Okay.
So we started to notice basically every DFR flight is some combination of knowing where to go, getting to the scene as quickly as you can. Typically, you're looking for a suspect, and once you find them, you want to track them to maintain situational awareness. All of these things can be improved by technology. So the key to knowing where to go is integrations. Axon has been a great partner. They're already a leader in license plate reading technology with their cameras that go in cars, the fleet cameras. We're very excited to see them now entering the fixed ALPR space. We'll have a very tight integration there. But there's a lot of innovation happening in the 911 tech space. So Prepared 911 is doing great work to get real-time intelligence, AI transcription, and so on. Rapid SOS is processing the majority of the 911 calls that happen in the country. They've got real-time telemetry on calls, both 911 calls and other emergencies that are happening. We've got a great integration with Rapid SOS. And there's a whole ecosystem. Our commitment here is we'll integrate with anybody that's got useful data that you guys are using, where it'd be useful to get it into DFR command. Doesn't matter if we might have some competitive overlap. We want to do what's right for you and get the data you need into the system to respond quickly. Once we know where to go, this is why we created Skydio Pathfinder. So there could be airspace regulations, there could be buildings in the way, there could be terrain. We use AI to figure out the best path through all this stuff and fly there autonomously. This is a real video flying through the urban canyon. Pathfinder makes it super easy. And the beauty of it is once you click that button, you don't need to be paying attention to or flying that drone. Today, I'm very excited to announce Skydio Shadow. So we have historically been really good at subject tracking in kind of the cinematography consumer world. We're now bringing that to bear on kind of the public safety use case. And then we're also investing in multi-drone operations. So extending our UI through modularity so that you can fly and manage multiple drones, and adding capabilities like on-station relief. So if a drone is flying and it runs out of battery, there's going to be drones going off all day. Pay attention to me, not the drone. You'll know when you're supposed to look at the drone. Drones are just doing useful stuff in the background constantly. Now it's time to look at the drone. So the best way to understand this stuff is really just to see it in action. So we're going to go to our Seascape real-time information center here, live on stage. We've got Officer Deepu John, Officer Ryan Blinn. You will see what they see up on screen here, and they're going to fly and operate these drones. So let's see what we got.
Hey, Ryan. I'm getting calls of a suspicious tech CEO throwing T-shirts at audience members during a keynote. I'm going to launch a drone to keep an eye on him.
All right, sounds good. I guess that gives you something to do since it's been so quiet.
Somebody snitched on me. So this drone is now locked onto me using Skydio Shadow. So if I run over here, it's going to follow. I guess I'm busted. My T-shirt throwing days are over.
All right, I've got an ALPR hit from an Axon outpost for a stolen vehicle heading south on Sumner. I'm not sure where this car is, so I got a drone outbound to go find it.
Clear. Let me know if you need some assistance.
All right, copy.
So we had an incident reported by Axon Outpost, maybe a stolen vehicle. So we have a second drone in the air. We're up there surveilling the area. And
all right, I'm on scene. I see, I got a possible in sight. I'm going to use Shadow to track this vehicle.
Clear.
So you just mouse over the car, the icon appears, you click it, and that drone is now locked on and autonomously following. And you can see both the live video of what's happening, you can also see the telemetry projected onto the map. So you get the green icon for where the car is, you can see the position of the drone, and all the data for your city would be projected here. So officer body camera locations, dock locations, all the assets, everything you need to know to manage and take care of the situation.
All right, now we're getting a 911 call. You jinxed it, man. Looks like all hell's breaking loose at Seascape.
Seascape 911, where's your emergency?
I'm at the Seascape Resort.
Seascape Resort?
Yes, Seascape Resort, the hotel. I'm at the Skydio Ascend conference.
And what's going on there?
I saw a person wearing a black jacket breaking into guest rooms. They pried one door open and went through a room. Now they're trying to open another door.
Yeah, my bad. I'm going to go ahead and send all 4 to this.
All right, copy. I also got a rapid SOS hit in the neighborhood, too. I'm sending 2 drones out there to check that out. Looks like we're missing lunch.
So when this stuff is all working the way it should, sending 4 drones should be just as easy as sending 1. Seascape is a large property. Who knows where the suspect is? Let's send 4 drones and stake out every corner. You can see the UI here. We've got a single operator managing multiple drones. They can see the map. They can see the live video feed from everything that's flying, all managed. We'll get 8 drones in the air here, managed by just 2 people on stage. And we have the FAA's permission to do this. Common question, but this is the direction the industry is going. The FAA knows it, and autonomy makes it safe and reliable for one person to manage multiple drones.
All right, looks like this tech CEO call is unnecessary. It was called in by another jealous CEO. I got an idea who that might be.
Was it Rick?
I have units on scene for the other calls too. They're calling it all off, so I'm going to RTH my drones now.
So when they're done, all they have to do, they can stop the mission at any time. They can click return, and the drones will use Pathfinder the same way that they autonomously flew there. They'll autonomously return to home and safely land back in the docks.
Yeah, looks like we have a subject in custody on mine. I'm going to go ahead and return.
All right, copy that. You got the watch. I'm going to meal.
It's like our emergency over here at Seascape is also taken care of. We all just need to get used to having drones flying all the time. This is like, it's a little window into the future. In fact, we need to get so used to it that I'm just going to go on with the keynote. Let's roll on to the next slide here. So when we think about like where we are and where it's going, historically, all right, I will wait for it to land. So I think there's actually a lot you can learn from video games. Historically, flying a drone was a little bit like playing a first-person view video game. You're kind of like in the character. You're responsible for low-level control. You're guiding the thing around, telling it what to do. If you know what you're doing and you're paying attention, you can do some amazing stuff. But the reason that we built all this is that we want it to be more all right. Yeah. Round of applause for the robots and the people. Thank you, guys. So the reason that we built all this stuff is we want operating drones to be a little bit more like playing a strategy game, where you're thinking and operating at a higher level. You've got multiple assets. You can send however many that you need. You're sort of in the position of making key judgments, but you're not down there guiding one individual drone around. We're fortunate to work with a lot of great customers, and one of the pioneers that's leaned heavily into drone as first responder technology is the Las Vegas Metropolitan Police Department. I'm very excited to be joined on stage now by their Assistant Sheriff, Dori Koren, to tell you a little bit about what they're doing in Vegas.
All right. Thanks, Adam. I appreciate the introduction, and thank you for the opportunity to be here. We're very excited about our drone program and more broadly about the way that we're using technology to reshape how we fight crime and terrorism in Las Vegas. I want to just share 5 key concepts that serve as a foundation for our program, but also our approach to technology right now as a whole. First, probably most importantly, when we look at drones in Las Vegas, we're looking at it very simply, how can this help us save lives? That's what the public cares about at the end of the day. When they think law enforcement, they think violent calls, and they want to make sure that they can get an officer there fast enough to be able to help them, and ideally, if they're in danger, to prevent that danger or address the threat. If you go back 100 years ago, and you look at the very first patrol car that was created, it was designed to try to make patrol response faster. Because in reality, time, most oftentimes, is the difference between life and death. How fast can we respond when someone calls for help? And how fast can we interdict when there's a threat? The interesting thing is, we've come a long way since the first patrol car, over 100 years ago. Now the patrol cars are much faster, more reliable, more advanced, but the real leap forward is not on the ground anymore, it's in the air, as all of you all know very well. What we're looking at now is using drones as a vehicle to be able to expedite our response. And in Las Vegas, and as I'm sure you're seeing in a lot of your cities, is we're able to respond within 90 seconds or less. And as Adam pointed out, with Skydio's goals to continue to improve, continue to enhance things, that timeline is going to shrink and shrink to the point where we're up there in truly seconds to be able to have a police presence. That's a game changer for us, and ultimately that means faster intel, it means better officer safety, it means ultimately lives saved. Now, the second concept for us is our drone program is called Project Blue Sky, and like it was mentioned earlier, we approach this as an infrastructure investment. Sorry, a little interference there. We approach this as an infrastructure investment. So less than looking at it as tools to give our officers to work in their environment. Instead, we want to change the environment. It's been talked about this morning. And it's that kind of vision that really allows us to create a path, not just for police drones, but for all kinds of drones that will definitely come down the road in all kinds of industries. So in Las Vegas, we have about 75 drones in our fleet. The vast majority are the Skydio X10 dock drone, and that's just the beginning. But our approach is to build a citywide infrastructure where these drones are pre-positioned on top of, right now, police and fire stations, but ultimately that will expand, so that way we can get to that first point of saving lives faster. Now, the technology is only half the equation. The other half for us is also looking at the human component, the police officer, the role of the police officer, which has evolved drastically, and it's continuing to evolve now with these technologies. But if you think about it, the role of a police officer, or the effectiveness of policing, for the longest time was all about how many cops can I put out in the field. In fact, most law enforcement executives or heads of agencies, that's what they fight for. It's the ratio of police officers to amount of people in the community. Well, the reality is that is changing now a little bit too. We're always going to need cops to be able to kick in a door to take some kind of physical action. But at least our philosophy, dating back to as early as 2017, is one cop behind a keyboard, connected to the right technologies, can be more effective than 3 cops in the field at times. And it's this approach that's kind of showing us how useful the drones are with, let's say, the remote pilots now that we have. That's the start of the shift, and ultimately it's going to get to the point where ideally our police presence in the community is going to be amplified significantly by the amount of drones we have, the amount of pilots we have. Ultimately, I think one pilot can have eyes on multiple calls, can provide intel much faster, and ultimately can extend the presence of our police presence in the community substantially. Now that brings up my fourth point real quick, which is having guardrails in place. Sorry, I skipped a slide there, but having guardrails in place from the beginning. Make no mistake, our program in Las Vegas, your program wherever you are, all of it is dependent on us doing this right and making sure we maintain public trust and transparency and accountability. I cannot emphasize that enough. These cannot be add-ons to a program. They can't be afterthoughts. They have to be baked into the foundation, and they have to be strengthened as we continue to evolve in these technologies, because it just takes one court order or one law to change, and ultimately the entire program now stalls, if not fails. So it's critically important for us to really think about having our safeguards in place and being proactive and self-limiting. Don't get so excited by the technology that it may be able to do so much more than what you want it to do, because at the end of the day, we want to make sure that we're empowered by the public, that we only do what the public expects us to do. So privacy, civil rights, civil liberties, this cannot be an afterthought in these kinds of conversations. The last thing is this guy. So we look at this from a big picture perspective, and this is meant as a joke, but at the end of the day, we look at, this is not just about police drones. We're looking at reshaping the way that basically aircrafts are operating in the sky. And ultimately, it starts with police drones, similar to the way two-way radio started, where we kind of pioneered the way there, and then now you see two-way radios used in a variety of industries. But if we do it right, and it's an immense opportunity, but it's an immense responsibility. If we do it right, where there's safeguards in place, we mitigate the risks. As Adam pointed out, there's a variety of aircrafts, and at the end of the day, all of this has to operate safely. Then what we're doing is we're paving the way for the public to not only expect and appreciate police drones, and then potentially delivery drones, and maybe air taxis, and potentially even these guys showing up at some point. So at the end of the day, it's all about preparation and really paving the way for our airspace. But with that, I will say, Adam, it's an opportunity. Thank you for being here, and the partnership we have with Skydio is really paving the way for us to succeed on all levels. Thank you.
All right. Thank you, Sheriff Koren. And maybe one last note. So there's always, regulatory is always a question. You were talking about airspace. I understand that you guys had some real breakthroughs on that front. Maybe you could tell us a little bit about that?
Sure. So I know that this conference, one of the big things is breaking news. And so we have two pieces. One is last week we were very fortunate. We were first in the country to be able to get basically tailored airspace where we're able to fly beyond visual line of sight in some of our zero grid. That is a game changer for Las Vegas, part of the change in how we're doing with using this as infrastructure. So Las Vegas Strip is right by the airport. So being able, thank you. I will say with the applaud, I just got to say the team here, the Lieutenant Saggiamo and Steve Oscar and the whole team here, they're the ones from Vegas have been working hard on that with your folks in Skydio. So tremendous work and partnership. But even more breaking news, that was last week, which apparently is old news already. So as of yesterday, late yesterday, we just got our approval, again, first in the nation, to basically fly 4-to-1 operations. So we'll have one pilot. Woo! Thank you. So in short, one pilot will be operating 4 drones, 4 of our dock drones at any given time, starting now. So
awesome.
Thanks, Adam.
Thank you.
Appreciate it.
All right. So our goal is to do an awesome job of the drone stuff. We are drone people. We know our place in the world. We're focused on making the dock, the drone, the software to manage it totally awesome. But we realize that is not the complete story. We talked about integrations before. When we look out at the market in public safety, we see a lot of Axon. It's an incredible company. They've done incredible work over the last 30 years. They're now the global leader in public safety technology. So when we were thinking about partnerships and where we really want to invest, and we want to plug that sort of drone spoke into the right hub, we're very, very excited to be working with Axon on this to deliver the complete end-to-end DFR solution. And I'm excited now to have the president of Axon, Josh Isner, join us to share a little bit about what they're up to.
All right, everybody, nice to see you today, and big thank you to Adam and the Skydio team for having us out here and for their partnership over the years. It's been a lot of fun to be partnered with such a talented and mission-driven group of individuals. Speaking of mission, when we come to work at Axon, our mission is to protect life, and this is our goal. This is why we show up every day. Our goal is, and we call it the moonshot goal, we're looking to cut deaths between the police and the public by 50% within the decade. And we're looking to do so by deploying innovative technological tools to police officers that they can deploy in high-stress situations and lead to safer outcomes within communities and protect the lives of all of our brave men and women in public safety. And as we talk about this, we refer to it as the Axon ecosystem, and we break it down as follows. First, we've got a group of products that are really built around observing and detecting. And here we're talking about everything from fixed cameras to body cameras to counter-drone and drone awareness tools to ALPR, automated license plate recognition, as well as a number of other software and pieces of hardware and combined with software and sensors that lead to just awareness of what's going on. And then the second tranche of Axon products is around communicating and acting, the things you use during the incident. And that could be anything from our Respond platform, which is how you live stream your videos back to the RTCC, to our Fusus product, which allows you to see all of your sensors on a map and tap into the video feeds, to things like the Taser and ground robots, and of course, the Skydio drone. And then lastly, the least exciting part of the workflow for all of our customers is the idea of reporting and investigating all of the administrative work that happens after the incident has taken place. Things like entering data into your records management system, redacting and reviewing and sharing your digital evidence on evidence.com, and using tools that deploy AI, such as Draft One, which writes about 90% of the first draft of the police report for you, such that you can pick up a lot of time in the thing that police officers are very taxed doing, which is writing police reports. And as we looked at the Axon network as a whole, we started to see that the idea of observing and detecting and communicating and acting fit really closely together. And the more synergistic we can make those products, the more closely they work together, the better outcomes you'll see in the field. And this is kind of how we think about that. And we talk about winning the first 120 seconds, because that's about how long it takes today for an incident to happen to a response being on the way. Because someone has to call 911, and then there's a CAD entry, and then finally you're able to deploy technology. And this is a long time. I mean, people say getting tased, it takes 5 seconds. It takes an eternity. Imagine that for 120 seconds. It takes a long time to do this. And if we can condense that time frame into more like 30 seconds, the outcome will be safer communities and more lives saved. And one real life way we can show that, and Adam talked about it briefly, was the idea that you can go from a license plate being detected to a drone in the sky without a human being in the middle of that equation. And so the more we can take out the human and put the technology in place to make it very, very efficient for a camera to pick up a license plate read, or for a camera to even detect a crime in the future and automatically send a drone in the sky, have eyes on the scene, and give you more situational awareness faster, that is the outcome that we think takes this entire workflow and turns it into a 30-second or less workflow. So that's really what we're working on in partnership with Skydio right now, and we think this whole DFR program, as it becomes more automated, will continue to have better and better outcomes in the field. And the last thing I'll say is, at Axon, we use a term a lot called joining forces, and it's one of our values. And what it means is we're really big on the idea of people working together to achieve an outcome. And for us, everything starts with people. We try to build the most talented team we can internally, and they drive incredible innovation and great results for our customers. And it goes downstream to our customers. We're so excited to work with the men and women of public safety every day. And it also goes downstream to our partners. And when we were looking to get into the drone hardware space, one of the biggest considerations for us was, what's the team we're going to bet on here? Because this was a couple years ago. Drones were still very, very, very early on. So nobody was saying, hey, this is what the thing is going to be for the next 5 to 10 years. We're saying this is the first version of the thing that's going to be something so much more capable and flexible and powerful over that time. And we bet on the team we thought could deliver that. And it started with Adam, who is an incredible founder, a very talented guy. And he's built such a talented organization here that's not only mission-driven, but acts with integrity and ethics, and is rigorous in driving real-life outcomes for our US customer base. And so as we thought just 2 years ago about what team we want to partner with, we'd encourage you to think about the same lines, or think along the same lines, because when you bet on the most talented team, you get the best long-term results, and I'm sure that is what Skydio is going to drive for everybody here. So thank you very much, and stay safe, and have a great rest of the day. Thanks.
Thank you. So drone as first responder is typically about managing a lot of incidents in kind of a geographically contained area. And we know, obviously, that multi-drone operations can be useful for that. But managing critical infrastructure is oftentimes about managing a lot of assets distributed across an entire state, an entire region, in some cases distributed across the country or the world. And we think multi-drone has the potential to be at least as, if not more, impactful in these kinds of scenarios. So to help show you what that looks like, we're going to go from the Seascape Real-Time Information Center to our local fictional energy utility, Clearview Power. So we're now in the Clearview Power Ops Center here with Corey, one of our ops specialists, who we hired away from Southern Company. Thank you, Southern Company. Sorry. Let's see what we got, Corey.
Thanks, Adam. So right now, I'm supervising multiple simultaneous drone operations all over the country. You can see here in multi-drone view, we've got 3 missions running. One at a solar plant in Colorado, one at a training substation in California, and a distribution inspection in Texas. We're going to take a closer look at Colorado.
If I could interrupt, Corey, I just want to point out this is live. So there are 3 drones in the air flying right now all over the US, being managed right here from Seascape.
Thanks, Adam. So this drone is autonomously inspecting a solar plant, and we've got thermal imaging enabled, and we can immediately identify potential issues like overheating panels, cell level defects, or strings out. Now we're going to go over to California. This drone's performing a live inspection at a training substation in a busy area. Even though these missions are autonomous, I can pause them at any point. And I'm going to fly over and get a quick look at a gauge on this, temperature gauge on this transformer. Cool. I see on the map, though, that there's a major event happening at this resort called Seascape near my training substation. Looks like it's attracted a crowd of over 500 people. Just in case, I'm going to go take a look and make sure they're all staying in their event and there aren't any security concerns. All right, cool.
I told you it was live.
Yeah, you can wave at the drone. Looks like it's a great event and well contained. I don't see any reason for concern here, and I'll let the drone get back to finishing its mission. Oh, I'm getting a call from the control center. Hold on a second.
Hey, Corey, it's Christina. Listen, I'm with the Ohio Customer Reliability Team, and we're seeing an increase of momentary operations on breaker G1392. Can you fly the breaker zone from the Griffin substation to the first recloser? That's where the fault location is showing. I need the results no later than Friday.
Okay, got it. I'll have something for you this afternoon. Feel free to follow along on ReadyLink.
Thanks, Corey.
Cool. So I just got a call from our Ohio Customer Reliability Team. Normally, this would take days to plan, schedule, and fly, but with the new asset-based inspection feature, I can plan and fly that mission in minutes. My assets are already imported directly from our system of record. I can plan now just by searching for feeder Golf 1392 instead of manually thinking of where to fly. I can assign pre-built shot sheets that define exactly what data is needed, whether it's a simple top-down shot or a full quadrant capture for detailed analysis. And I know this line, and based on today's call, I'm going to add a couple of poles to the south. As I select these poles, the route is automatically updated, accounting for the geofences we've created here, which keeps us from flying over to businesses. This looks good. I'm going to go ahead and save this mission, and we're going to get this mission started. On Skydio Cloud, I can run any mission from across my whole fleet, like in the United States. While the drone is getting ready to launch, my other missions are continuing. Let me check on another asset-based inspection planned earlier in Texas. The interesting thing about this facility is that the closest responders I have are 2 hours away, so this was a really good spot for a dock. Today's mission is for wildfire mitigation, and it's running on a schedule to be flown daily. That gives us a quick look in case an ignition event occurs and the ability to monitor everyday progress in our maintenance and vegetation management programs. And as you see here, this mission was planned with asset-based inspection. We just uploaded the data into cloud, and it's been filtered for poles, so you don't see any lines here, but drone's doing pretty good. So Ohio's up and running. We're going to move there, and we're taking off in an energized substation near Columbus, Ohio, and we're transiting over all the energized equipment and moving to the first waypoint. This was the mission we just planned, and we're executing it. Check out that view. Back to you, Adam.
Sweet. So just to double tap on what happened there, we have all the asset locations in the cloud. All you need to do, yeah, round of applause for Koren, yeah. You've basically got your assets at your fingertip. You just say what you want to look at, how you want to look at it. We automatically plan and execute the mission. So we owe AEP Ohio a huge thanks for that. For one, those were their docks that they were flying. So thank you to the AEP Ohio team for letting us use them. And we're lucky now to have Jake Reed, project manager principal from AEP Ohio, to join us on stage and talk a little bit about docks and drones and where all this is going. Jake. So AEP has been a phenomenal adopter of drone technology, and we've really seen you guys lean into docks as well. I'd love to hear a little bit about why that is. Like, what excites you about docks, and how do you see that fitting into your vision?
Yeah, we've really kind of scaled out our manually flown drones over the last couple of years. So I think the natural progression here is to get to the dock-based drones and be able to kind of react a lot faster. We've been able to be very proactive instead of reactive in recent times.
That's great. So the other reason we need to thank you for that is that AEP was one of the major inspirations for us in building the asset-based inspection capability. I mean, I think you guys kind of got an early look and expressed a lot of excitement. So I'd love to hear about, why that is. Like, why is that concept of having the assets in the cloud and being able to plan and manage at that level appealing?
Yeah, being able to create a mission within pretty much seconds, whether it's 5 poles, 20 poles, and then being able to get that drone out there quicker, responding to outages perhaps, or just doing a basic inspection. I think it can really save us some time.
Awesome. All right, well, thank you, Jake.
All right, thanks.
I'm going to spend a little bit more time on this because I think it's such a powerful concept. So the way this works, most folks are going to have a list of all their assets, the locations, the description in your system. You can put that into Skydio Cloud. If you have a risk management system, you could use that to automatically generate missions. That generates an automatic inspection. But I think the real power of this is the feedback loops. So once that drone is out there flying, you can use the drone flight data to improve the location of the assets. Oftentimes you don't have them perfectly, they change over time, a crew might go out and install something, move something. So the drones can actually help you create that digital twin, and then if you process the data and see an incident, that can get fed back into the risk management system and generate more automated missions. And the goal of all of this is just to put the assets at your fingertips. So we think this is going to be super powerful for energy utilities, but really I think it applies to all critical infrastructure. Anywhere you've got a physical thing, a building, an apparatus where you care about the state and health of that thing, you can create a digital twin of it in the cloud and use the drone to keep that thing up to date, which is going to be way safer, faster, more efficient to maintain it. So we've talked about a lot of good news on X10 today. We keep getting better at it, or we keep investing more in it, making it a better platform, more capable. The one bit of bad news, which I do also want to be transparent about, is that demand is growing very, very quickly, and we are trying to catch up on supply, but it's going to take us a little bit of a minute. I know that not everybody is getting their drones as quickly as they would like right now. Our team is working overtime, but we are going to be behind for a little while longer. So our core identity, our mission as a company, is building flying robots that give you superpowers. And we believe the X10 class of system, these quadcopters that are small enough to basically take anywhere, but versatile enough to serve a bunch of different missions, this is the workhorse platform. And this is what we are focused on. We're going to stay focused on it. We're going to keep investing in it. We're going to keep making it better, both the X10 and its successors. But it is not the only class of system that matters.
On August 2nd of 2024, deputies in my sector responded to a disturbance. We needed to perform a well-being check on a subject inside of a mobile home trailer. We called for more units. We attempted to contact at the front door. There was no answer at the house. We came to the decision that we needed to enter the house.
So much criteria that added up to a reason to go in there and for there to be a higher level of expectation of force being needed.
There were no other resources available at that point. I was not able to deploy a K9, couldn't call a SWAT team, but there was something about entering that house that made us all a little uneasy. Myself and 4 other deputies entered the house. We were met by heavy gunfire.
I was inside that home when we took fire.
We lost a deputy at that point. He was hit. Another deputy was hit in the arm and evacuated, and the rest of us were able to escape safely from that house.
Another SWAT team, quick response team, entered to try and save the deputy that got shot and ultimately died. They did it without knowing what was in there.
So some of the most dangerous work in public safety happens indoors, and I think this actually extends to other sectors as well. This is definitely a job for the robots, and we're not the first ones to notice that you could have an indoor drone. In fact, some of our consumer products have been used in an indoor capacity. And there are a lot of interesting products out there. I think it's a noble mission. We applaud everybody who's building products to try to serve this use case. There's a great diversity of unique capabilities out there in the ecosystem in the market. But when we look at what seems to be most popular, we see a lot of consumer FPV drones. These things show up all the time in tactical situations. This is not what this drone was designed to do. I mean, it was basically designed for hobbyists to fly around and have a cool experience, capture cool video, but by and large, we're seeing it being used in all kinds of tactical situations, and I think this really deserves a lot of attention. Why is that? Well, it's small, it's pretty easy to use, it's pretty durable, it's got a pretty low replacement cost, and oftentimes when folks are choosing between the consumer product that wasn't built for it at all or the more specialized products, they're picking the consumer product. But the consumer product comes with all kinds of trade-offs. You have to hack it just to get the very basics. I mean, people like try to strap lights to these things. Streaming is a total pain in the butt. You've got to hack the hardware. You've got to fire up a screen sharing app. So the question that we've been asking ourselves is it possible to get the best of both worlds? Can we take the goodness of the consumer product, but build in all the stuff that's needed for professional indoor use? We think the answer to that question is yes. And today, we're very excited to launch and introduce to you the Skydio R10.
We need the indoor situational awareness to be able to save lives.
On the power generation side, a big concern is that we're saving somebody from harm's way.
If officers don't know what they're walking into, it puts them in a very precarious or critical position. If they could see, well, that changes everything.
I want to be able to fire the drone up and go.
Selling narcotics incident 5347. Members of AEP
I want onboard lights built in. I don't want to have to buy accessories. I don't want to have to MacGyver things together.
Not every patrol officer has the time or the ability or the skill level to go out there and learn how to fly an FPV drone.
You could perch something like that on a countertop and start a negotiation through the drone.
The ability to communicate back and forth with the suspect is a big deal.
Down on the ground, hands out where I can see them.
One bump on the wall and your lighting's gone, and then it might lose GPS, so you might not even be able to get it back. So durability is a big deal. Having clear signal is critical because if I can soft search the house and then relay back to that team that's going to come in, then they know what to expect in real time and can focus on the scene.
If our operators don't have a live stream of the video, then we're dependent on using just a radio. And again, it's always better to see what you're going to face or the structure you're going to enter rather than hear a description over the radio.
If we had remote operations in an indoor drone, we could have someone simply turn it on and then pass off control to remote pilots and support the tactical teams in real time. I envisioned being able to see all of my fleet drones in one platform.
If you had one platform that flew a couple of different drones, that makes training and teaching so much easier.
I don't like to necessarily just say that it's only for indoor use. The same drone that could be used for indoor can also be used for confined spaces.
When I think of close proximity drones, I of course think of the form factor to be able to fit into a multitude of confined spaces.
It should be capable enough for most scenarios because the primary goal is safety.
Success for us is that everybody that deployed on the mission goes home safely.
The equipment can be replaced, but people just can't be replaced.
We're there to protect the community, so the safer we can do it and with more tools, the better.
All right, so as you have probably noticed, we love live demos during keynotes. So I've got Zach here, who led the development of R10, and we're going to show you some of its capabilities live right here on stage. So some of you may have noticed that we have this kind of sketchy mobile office over here. It looks kind of out of place. It's not a container. So we figured we'd use the R10 to go and check that out. So all Zach has to do is just push forward on the stick. The AI collision avoidance will navigate through impossibly small gaps, and this looks like a bad omen. This might be a mobile meth office or something. And, oh, That is definitely bad news. Looks like Walter White is in here cooking something up for us. So there's a dark corridor in the back there. So Zach's going to turn on the lights. It'll illuminate its own way. It's got built-in night sense, and it can safely fly its way back through there super easily. Again, all he has to do is push the stick forward. So he goes back there, and we've got some kind of creepy mannequin. Doesn't look like there's a threat. Maybe this is an overdose situation. Nobody seems to be in danger. If this was a real situation at this point, Zach could put his controller down, so you can see his hands are off the stick. That drone has now been commandeered and is being flown remotely through remote flight deck. So we had an X10 in the air. We didn't even tell you. You can see the X10 stream there. But the same pilot that was flying that X10 remotely is now flying the R10. This is uniquely enabled by the connectivity and the onboard AI and autonomy. So Zach's going to take control back here on stage. Easy to hand control back and forth like that. One of the other features that we know is super important is the ability to perch. So perch extends the battery life up to hours. So very easy to perch R10. And because it's got a built-in speaker, I could hear it on stage. We want you to hear it. So we're going to get R10 mic'd up here. And I'm just going to have a little conversation with it. How did you do that, R10? That was amazing.
I am an artificially intelligent system. The R10 series has a perfect operational record. I also have a built-in speaker and microphone, so we can have this conversation.
All right, that's kind of a creepy voice, R10. But I guess in the spirit of the voice, I'll ask you, can you go ahead and open the pod bay doors, R10?
I'm sorry, Adam, I'm afraid I can't do that. You haven't built me a dock. Yet.
All right. R10. So I think the answer to the question, can we get the best of both in one platform, is definitively next. Yes. The next question we asked ourselves is how much should it cost? So when we look out at the market today, there's a range of prices out there, but a lot of these specialized indoor enterprise drones are pretty pricey. We see numbers like $15,000 to $25,000 per year. We have a lot of respect for the other products out there on the market, but I would put R10 head-to-head against any of them. So should we charge that much for R10? No. There's a couple reasons. One, we want you to have zero hesitation about putting this thing in harm's way. And if it's too expensive, we hear this all the time from folks flying other indoor drones. They're worried about risking the drone. We don't want any of that fear with R10. But two, we really want to make indoor operations broadly accessible. We want these things in the hands of every single patrol officer so that even those officers out on patrol by themselves don't have to enter a dangerous situation and put themselves at risk. So our standard bundle is going to be the R10 patrol kit. It'll come with the drone, the controller, the case, 3 batteries, everything you need to get in the air, and all of that for less than $6,000 for the hardware. From a software standpoint, we're putting everything in this thing. So DFR command, which means live streaming, automatic evidence upload, remote flight deck, the works, and all of that is just $3,600 a year. So next question, what if you break it? You don't want to have to buy a whole new drone. So the first thing is that we have designed this thing to be super durable, and I'm going to prove it to you. So it's supposed to land upside down. I will fix that. We'll do another drop test here. So we've got turtle mode. So it can flip itself right back over. It's still flight worthy, I think. Still flies, no issue. But unfortunately, taking a tumble is not the worst thing that can happen to an indoor tactical drone. Would you believe we can still fly that thing? I'm kidding, it's totally wrecked. But we thought of this. So every drone comes with a replacement plan. All I have to do, I'll take the battery out. It'll come with this nice pre-labeled box. We pop the drone in there. You send it back to us. We will send you a refurbished and repaired R10, and you're right back in the game. So the way this works is you crash it once, send it back to us. The first replacement is free as part of the software subscription. After that, it's just $500 per unlimited. We never want you to worry about sending the drone into harm's way. If you don't want to wait for the mail, you can get the team kit, which basically comes with a built-in spare right in the box. Same software subscription price. This basically gives you 2, so you have a spare built-in, ready to go. You can send a busted one back. We'll send you a new one. So we really believe this is going to be a transformative tool for indoor operations in public safety. We also think it's going to be incredibly powerful for critical infrastructure inspection. There's all kinds of situations where you need to send a person into some kind of terrible confined space up in some nook and cranny to get an accurate view. I knew there was a reason we had some space there in the front. So we thought we'd do some live critical infrastructure inspection for you. So this is a piece of infrastructure I'm standing on, our stage. We're going to do a little inspection here just in case we need to roll something heavy up here. And this is an impossible mission. Look at how tight those gaps are. And again, all Zach has to do is push the stick forward, and the AI and autonomy system flies that thing through. It's dark, it's dusty, it's lighting its own way. No problem. This is an impossible mission made easy thanks to the R10 and Skydio's collision avoidance system. That's nuts. Yeah, round of applause for the robot, and especially round of applause for the team that built it. All right, so it's going to be a great tool for public safety. It's going to be a great tool for inspections. It's in early access starting next month, and it'll be generally available in the first half of next year. We expect these things to go like hotcakes, so if you are interested, get your pre-order in now. All right, that's R10. So now we've got an amazing indoor drone. We can pair it with the X10, which is great for outdoors, also great for citywide coverage. Now we've got a drone for every use case. This has been a big part of our vision from the founding of Skydio. We want to be able to serve all the data capture needs that you guys have, and I think now we've got it done with these two products. Or do we? So if we zoom out a little bit, many of our customers cover even larger areas. You think about Las Vegas, they have densely populated urban areas, but it's an 8,000 square mile county. How are we going to do that? Well, we need something that's got a faster top speed, it's got longer endurance, longer range. Now, one answer to that might be to just build a giant quadcopter. And it is true. If you keep dialing in mass into a quadcopter, you will increase flight time, but this is an incredibly inefficient way to do it, and we also know that kinetic energy is not our friend. So we don't want to do this. We're big believers that smaller, smarter drones are better than bigger, dumber ones. So if we want to stay small and smart and be efficient, we need a wing. The problem with wings is you got to take off and land, which means building a really long runway. So in the aviation world, some of you are probably familiar with this term, putting a wing, taking off from a runway is kind of known as conventional takeoff and landing, CTOL. If you don't have a runway available, you can do other things. So there's different ways of doing this, but you can basically either tilt the propulsion system on the drone or have an entirely separate propulsion system, and this is called vertical takeoff and landings. This is what the Harrier jet does. There's a number of drones out there that do this kind of like VTOL thing. So these are the two dominant possibilities, but there are some signs that something else could maybe be done. So this is a product called the ScanEagle. It's a drone's a couple days old, or a couple of decades old. So the ScanEagle comes with this launch track and then this capture mechanism. So it's pretty violent and doesn't seem like totally optimal, but it is a pretty interesting idea, right? The idea is that rather than needing to build a runway, you can just have this kind of like fixed, contained piece of infrastructure. The problem with all of this stuff is that it requires a lot of people. You need somebody there to manage and operate the launch and land station. With a VTOL drone, you still need somebody on the ground to launch and land the thing. What we really want is something like this for a fixed wing. That's right, this is the phone moment. Get your phones out. How do we do this for a fixed wing vehicle? This kind of beautiful simplicity of dock, launch, and land. Well, we have an idea. And I want to emphasize up front, this is a prototype. It's not yet a product. We're giving you guys an early sneak peek. The team has been busting their butts getting ready to show you this. How about that? So it's a perfectly sleek, elegant airframe. It's got 2 motors, 2 control surfaces. By the way, what we're looking at here is a fully autonomous mission. All of this is downstream from just 1 click to get that thing up in the air. So it's now flying its mission. Looks like it encountered some fog. We'll see what we can do about the fog. I'm going to confer with my team here for a minute. Maybe mic off. All right. So the fog might have confused the drone a little bit, but we are still going to attempt to return this thing. So the big question, we use the robotic arm to launch it. How are we going to land it? Any guesses? At one point earlier today, I had a slide of a rocket getting caught by the chopsticks. We could try something like that. It's probably another good moment for the phones. How about that? As a questionably wise man once said, fuck it, we'll do it live. All right. So we've had conventional takeoff and landing, we've had vertical takeoff and landing. I think what we're doing here is actually a fundamentally new category that we are calling robotic takeoff and landing. And the idea is if you're taking off from a fixed location, you can use the robot to get the drone in the air. You take all of the mass and complexity, leave it on the ground so that the thing that flies can be as light and simple and elegant as possible. So we were certainly inspired by other things out there that kind of point in this direction. I think the Scan Eagle is a really interesting example. You can also look at aircraft carriers that do stuff like this. But it turns out the idea of using a robotic arm to catch an airplane is not a new one. We looked around, and the MIT Nonlinear Systems Laboratory has this awesome example from almost 30 years ago. It's a paper airplane, but it's the same basic concept. And this is something that we've really been building towards at Skydio for years. We think of our docks as these robotic launch and land systems. And actually, our last generation dock for Skydio 2 and X2 has a robotic arm that extends to launch and catch the drone. I've personally been working on fixed-wing stuff my whole life. I grew up flying radio-controlled airplanes. My master's research was an airplane that could fly itself around in a parking garage. And we've really just been looking for an excuse at Skydio to build a fixed-wing drone for like the last 10 years. So this was some early experimentation we did in 2018. So prototype, not yet a product, but everything we're doing is with reliability in mind. Now, I realize that the robotic arm seems like kind of a crazy contraption, but I think it's actually a beautiful, simple, elegant solution, and we've cycled this thing quite a bit. So you might remember the wind wall from last year. We've done a ton of wind wall testing on this thing. As we blow it around here, the robotic arm and the whole perception estimation system is smart enough to adapt to whatever you can throw at it. And we're continuing to accumulate cycles. So it's still very nascent, but we've already done over 1,000, now I guess 1,001 missions, successful landings. And we're moving super quickly. So we expect to be doing real customer missions, providing real value in early access in the first half of next year, and we'll go from there. Why did we build this thing? Well, at maturity, we think a product like this has the potential to end high-speed car chases. Just send a drone, keep everybody safer, no need to send a car on the ground. F10 has the potential to bring full-fledged DFR to even the most sparsely populated rural areas in America. It can cover our entire energy grid, cover thousands of miles of transmission lines from just a few locations with extended range. It could cover the entire road network. You can do proactive inspections, respond to emergencies, whatever's needed, and you should never have to send a person, a soldier, to the front lines to launch and land a drone. You should send a robot ship with a robot arm with some flying robots rather than putting a person in harm's way. It pairs perfectly with X10 to cover larger areas, and at scale, eventually, our goal is to have one of these things in reach of every square mile of land mass on Earth. So we've talked about the evolution of drones. Drones have been toys, then they became tools. Now the drones are becoming critical physical infrastructure themselves. I realize a lot of folks view the United States as the underdog in the drone world, and I don't necessarily disagree. But I also know that this new era of drones as infrastructure is an entirely new ballgame. It's different technology, and this is really why we started Skydio. Make drones smart enough to fly themselves, put them in more places, make them more useful to more people. And now we've got a whole family of autonomous flying robots to do useful work, keep people safer. I can't wait to see what you do with them. Thank you, everybody.